Alright guys, so I figured I would kind of demo or explain how I took some high-powered LEDs and created a daytime running light as well as switchback sequential turn signal out of that. And it's not very hard. It's more grasping the concept of the math and LEDs and what chips you're using and what drivers to use and the appropriate amount of current and so on and so forth. So for this example here, what we can go over is the LEDs I'm using, the drivers I'm using, how I calculated why to use those drivers, along with the LED sequential module that we're using from 2S Performance, and how it all works. So let's first start with the LEDs. So these chips here are what I know them as power LEDs or 3-watt LEDs. You can find them all over AliExpress, eBay, Amazon, etc. So they come in a variety of wattages: 1 watt, 3 watt, 5 watt, etc. Basically what these here are bicolor LEDs. So they have both a white and an amber chip in them, all in one package. So why I'm using them instead of, say, alternating a dedicated white and a dedicated amber is because it allows me to get a greater density of uniform light when I can basically use twice as many whites and twice as many ambers for the DRL and turn signal combined. So you have greater density of light, a bigger punch per se for the length of LEDs that you have in the small area or application that you have to work with inside a headlight or tail light or whatever. So the first thing you kind of need to know is, with the LEDs, you need to know their specs. So on these chips, again, you have a white and an amber. They are basically both 3-watt LEDs. 3 watts meaning their optimal current rating that runs through them is 600 to 700 milliamps. So the white chips require 3 to 3.6 volts, and they can run again at 6 to 700 milliamps. And the amber chips require a lower voltage of 2 to 2.4, but they also run at 6 to 700 milliamps. So with that being said, how you then decide on what drivers you use depends on how you're going to wire them. So if you wanted to power one of these chips, you would again either supply 3 volts to the white contacts or 2 to 2.4 volts to the amber contacts. Alright, so let's talk about how I have these wired and the drivers I'm using. So I have all these wired in series. So we have 6 LED chips. Both the whites are wired in series and both the ambers are wired in series. However, they're wired a little bit differently. So let's just focus on the whites. So I have all 6 of the white chips in series. Now if we go off of 3 volts each, that's 18 volts needed to power this series of LEDs. Now the ambers, we have 3 in series and then another 3 in series. That's why we have 2 different drivers down here powering each set of 3 and 1 driver up here powering all 6 for the white. So how I determined on what driver to use is knowing that for my 6 series of white LEDs at 3 volts each, I need a total of 18 volts to drive them. Now, white will be my DRL, so I'm going to drive them at 1 watt. So 1 watt meaning about 300 to 350 milliamps. This driver here is a 300 milliamp driver, constant current driver, so that takes care of my current needs. And it is also able to accommodate up to 4 to 7 LEDs. So the specs on that driver is basically an input voltage of 12 to 24 volts. So it will power up anywhere within that range, which is, you know, a car battery and an alternator setup. And the output or working voltage is anywhere from 9 to 24 volts, again at 300 milliamps. So as long as your series of LEDs or your array of LEDs that you're driving is between 9 and 24 volts as a requirement, in this case we need 18 volts, then it'll run them just fine at that constant current. If you're below that or above that, then the driver can't regulate, and it's basically like running them without a constant current source, in which case they're going to overheat. So that's really all you need to figure out is the requirements from the LEDs based on how you have them wired in series, what the total voltage is, and what you want to drive them at. And then you'll know that you have to find a driver that has a basically a 12 volt input range and an output working voltage of your required total voltage here. So that's the white driver. Same concept for the amber drivers, except I split them up in sets of 3. And basically why I did that is because when we talk about the sequencer, each channel of the sequencer is going to basically sequence 3 at a time. So the smaller amount of LEDs that you control, the more granular of a sequence motion you can achieve. However, you only have a maximum of 15, or theoretically 16, but if you're going to use one for a DRL, you really only have 15. 15 individual output channels for the turn signal. So if you only have 15 LEDs in your entire array, DRL setup, then you could do one at a time. I'm going to have a total of 36, so I'm basically splitting it up in 3s, which is a happy medium to give me a nice fluid motion and control them how I want. So talking about these, right? So these drivers, they look the same, but their specs are different. So these are what I'll call 6-watt LED drivers, and basically they drive at a constant current of 600 milliamps as opposed to 300. I forget the working output voltage, but anyway, I have them wired up with three in series each. So now that I've kind of went over the LEDs, how they're wired, and the different drivers, I will talk about the sequencer here. So this is a 2S Performance series sequencer. It's a very good sequencer. Combines DRL functionalities with Switchback sequential turn signal functionalities all in one. You have 16 total output channels. 4 of them you can dedicate, I'll say up to 4, you can dedicate as the DRL just by these dip switches. But the awesome thing about these is the fact that each channel, I think, is able to handle 3, maybe even 4 amps. So that's why it's nice to use these high-powered LEDs. You can get a lot of output, a lot of punch by using this the sequencer. Your Go sequencer, your Course of Motions, they're all made to, the MOSFETs on them or whatever are made to only handle like 250 or 300 milliamps per channel. So quite the difference here. Alright, so I'll hook all this up and then I will demo it functioning. Alright, so we have everything hooked up here. basically what you do is on all of the drivers, you take the positive lead and you hook that to your constant 12 volts. And then on the negative side of the driver inputs, you hook that all up to your DRL switch negative outs and your turn signal switch negative outs. So then when you basically give the board power, your DRL is on. So right now, right, with those drivers, we have two drivers at 300 milliamps each. This one's powering 6 LEDs in series. This one's powering 6 LEDs in series. So you're looking at about, a little over half an amp right there. So now, when we trigger the turn signal, it switches back to your white. So the turn signal, I'm not sure if you can tell in video, but it's actually twice as bright as the white DRL. So with all those lit at the same time, you're basically pulling, you have 4 drivers powering 3 LEDs each at about 500 to 600 milliamps. So you're basically looking at, 2 amps or so right there. Hopefully this helped someone, kind of understand how you can play with LEDs and wire them up with constant current drivers, and then incorporate some sort of sequencing board module to animate them for your turn signal and such. Highly recommend the 2S Performance LED drivers. Go support Ed. Definitely a high quality board, well made, and very affordable. One thing I will mention though is, going back to the drivers that I didn't say previously, is you don't have to wire 6 in series with one driver and another 6 with another driver. I mean, you could get one driver and power all 12. So it really comes down to what you're trying to achieve and the room you have inside of your application to store these drivers and whatnot. I mean, they're not very big. They're literally the size of a nickel. But again, like I said, I'll have about 36 LEDs total. You're only looking at about less than half of that here. So what's this, 12 of them? So they're going to be more of a C shape when I actually wire them up in the housing. But yeah, I mean, you could do one boost driver and power them all for the DRL, or it's all up to you. It's all up to figuring out the application and what works for what you're trying to do. But these drivers are pretty cheap. Again, get them off of Chinese eBay, and yeah.